Hello everyone, welcome back to International Trade. I'm very excited today because we're gonna start our first model, the Ricardian model of international trade. And I really enjoy this model because I actually remember when I first learned it. It was 10 years ago, I guess 11 years ago almost. And I was one of those that believed that, say, the trade of Italy with China was only due to the fact that Chinese workers had such low wages. You heard this a lot, right? You heard this a lot that countries such as Denmark or the US or Italy or a lot of high income countries tend to import a lot of goods from China. And the typical explanation that you can hear around is that that's because Chinese workers have very low wages. So if the cost of labor is so low in China, they are very competitive, and so the Italian, the Danish, the US companies cannot compete with them, at least in terms of prices, right? Well, it turns out that I had it all backwards. And that's what the beauty of the Ricardian model comes in, because it's a simple model that is going to tell us a lot of things. It's going to tell us why countries trade. It's going to tell us what they trade and why is it that some countries have higher wages or lower wages. Right? So let's see about that. I'm aware that most of you have already studied the Ricardian model in a previous course. So I'm going to be relatively quick in covering this model. And I will point out what are the new things that we're going to do in this course. But so the outline is fairly standard. We're going to start with the main assumptions of the model. Then we're going to look at the autarky case and then move on to free trade. This is going to be the typical thought experiment that we're going to do in this course. We're going to have a model, suppose that no countries trade, and then countries begin to trade. And we're going to study the effects of that. And finally, we're going to close the lecture with some empirical evidence on the prediction of the model and some empirical evidence on the trade patterns of Denmark. And we'll also conclude with the readings of the paper from Autarky and Gobert. So the Ricardian model comes from David Ricardo, which is a classical economist who in 1817 wrote a very important book called On the Principle of Political Economy and Taxation. And chapter 15 of that book is the model that we're going to cover today. Back then, David Ricardo had a very important problem to solve. He wanted to convince the British authorities to trade with Portugal. Britain was starting to have a lot of surplus of textile production, and they wanted to export it. And if they export it to Portugal, that perhaps is better than England in producing anything, what can they do about it? And so this is going to be the thought experiment that we're going to run today. We're going to not necessarily look at England and Portugal. We're going to look at two countries, home and foreign, and be very original with names. And asterisks are going to denote foreign variables. We're going to have two goods. Okay? It's going to be a price PI for good I and a quantity YI. Now, this idea of having two countries and two goods is an assumption that we're actually going to carry with us for a while. Then there's going to be only one factor of production. Bear with me in the future lecture for economies with more than one factor of production. And the factor of production is going to be labor. It's going to be L, the total number of units of labor in the home country, and L star, the number of units of labor in the foreign country. Now, there's going to be perfect mobility of labor across industries. Okay? Now, labor is instead going to be immobile across countries. So the idea here is that if you're a worker, you can move across sectors. Okay? You can work in the textile production or in the wine production, but you cannot exit Denmark and go work in another place. Okay? Now, consumers are going to have identical homothetic preferences. is going to be a non-trivial assumption, although we're not really going to see the consequences of this assumption for a while. But the idea here is that the budget share of consumers do not depend on income. So given the prices, if a poor consumer purchases 50% of its income on beer, the same thing will do a rich consumer. Okay? And this is just so that the patterns of trade, so what countries trade, is going to be just determined by supply factors and not by demand factors. But I will come back on that. Then there's going to be a wage W, W star for the foreign economy. It's going to be perfect competition. So there's going to be infinitely large number of very small firms, infinitesimally small firms, who take prices as given and decide how much to produce of the two goods. Of course, there's no barriers to entry, so firms can enter in any industry. Finally, the technology, which is the most important part of this model. It's also going to be relatively simple. The technology is going to be represented by unit labor requirements. So AI is the unit labor requirement for good I in the home country. So that means how many units of labor you need to produce 1 unit of output for good I. And A star, I, is the unit labor requirement for good I in the foreign economy. Okay? So given these AIs, we can characterize the equilibrium in the model. We're going to start with autarky, and very simply, the equilibrium here is going to be made by the fact that markets clear, and so the supply equals the demand. The supply is determined by production. We're going to represent that with the production possibility frontier. Consumption is going to be represented by a consumption possibility frontier as well, which is the budget line, and with the utility function of the consumers, and then markets will clear, and we're going to be in equilibrium. Now, the production possibility frontier is something that you all know. So it shows all the possible combinations of the two goods that can be attained when the economy produces in an efficient way, meaning it employs all the labor. And so to draw it, it's relatively simple here because the unit labor requirements are constant. They do not change depending on the number of units of output that you produce. And so if you write out fairly simply the full employment condition, so the fact that workers can only work in these two sectors, then you derive this production possibility frontier. So L over A2 is the maximum unit of output that you achieve of good 2 if all workers L are employed there. If you take the number of workers and you divide it by the unit labor requirement, you get the total production, right? Because 1 over the unit labor requirement is the marginal product of labor. Now, the most important object here is the slope of the production possibility frontier, right? And it's very important to remember this. I don't encourage in general to memorize things, but this is a very useful thing to memorize because it says that the slope of the production possibility frontier and really of any production possibility frontier equals the opportunity cost of the good that is on the horizontal axis, in this case, good 1. So the slope of the production possibility frontier here is telling us how many units of good 2 you have to give up to get 1 unit of good 1. Now, we can reason that through. If you want to produce an additional unit of good 1, you need A1 unit of output, right? That's the unit level requirement for good 1. And how many units of good 2 are you giving up if you need A1 workers? Well, you're giving up whatever these A1 workers are able to produce of good 2. And what each worker can produce of good 2 is 1 over A2. Which, as we said before, 1 over A2 is the marginal product of labor in industry 2, right? So if you want to produce one additional unit of good one, you need A1 workers. And if you divide the A1 by A2, you get the total number of units of good 2 you're giving up for good 1. Now, obviously, a disadvantage of having this to record these videos and not seeing you, I cannot really tell whether I'm going too slow, whether what I just said made actual sense, because I probably in class would have pointed very emphatically to the various A1s and A2s that I'm referring to. And so if this was too fast, just please pause and go back and watch it again. If this was too fast, sorry, if this was too slow instead, well, we're gonna move along now. Let's look at consumption. Now, it's obvious for given your curriculum that in Autarky, the production possibility frontier equals the budget line as well. In Autarky, what you can produce is also what you can consume. Consumption is bounded by production. And in particular, one can show that the slope of the production possibility frontier, which was the opportunity cost of good one, is actually equal to the relative price of good one. The thing that's interesting about this is that there is a tight relationship between the technology, the unit labor requirements, and in particular the relative unit labor requirements, and the autarky price. So if the price of good one increases, it means that you need more unit of work or labor to produce good one. Right? Now, you can get this relationship fairly easily by running out the budget line, but another way to look at it is to think about the fact that workers are mobile across sectors. So the wage in industry 1, I remember this is perfect competition, so workers are paid the value of their marginal product. So if a worker is working in industry 1, does something, produces 1 unit of output, right? He sells it for a price P1. To produce 1 unit of output, he needed A1 units of labor. So P1 over A1 is the value of the marginal product of labor. Because as we said, 1 over the unit labor requirement is the marginal product of labor. Multiplied by the price, you get the value of the marginal product. Now, if you produce in both industries, it must be the case that the wage of workers in the 2 industries is the same. If the wage in industry 1 is higher than in industry 2, nobody works in industry 2. Right? So if you set these 2 wages equal to one another, you derive exactly, very quickly, this condition. The equilibrium in the model is going to be determined by the point in which the utility function, in particular the indifference curve, is tangent to the production possibility frontier. Right? We know that in the problem set you'll actually solve for it. Now we can just use the graphical solution. And so there's going to be a certain number of units of good 2 and good 1 that are produced and consumed in autarky. Now, the foreign economy will behave exactly in the same way, right? But we're going to make some assumptions about the technology of the 2 countries. So we're going to say that the unit labor requirements for good 1 and good 2 in the home economy are lower than in the foreign economy. So this means that the home economy is more technologically advanced, is more efficient, because to produce 1 unit of output, it needs fewer workers. This could very well represent the case of Denmark and China, or Italy and China. Right? So the idea that some countries are more productive than others, more productive because of technology, because of the capital that they're endowed with, because of a lot of things, right? Which we'll talk about in the future lectures. In this case, we're going to take it as given. Some countries are more productive than others. And this is also a very tough spot in which we're putting ourselves, because oftentimes it is very intuitive to think that countries produce what they do best. It's also very natural to think that you will produce something in your career, in your job, that you do best. Okay? So what if a person, or in this case a country, can do better than a foreign economy everything? Is there still a point in trading? Well, we see that indeed that is the case. But a little bit of a terminology here. First, we're going to say that the home economy has an absolute advantage in both goods because it has a better technology. However, we're going to make the assumption that the relative unit endowments are such that the opportunity cost of good one is lower at home than it is abroad. I recall A1 over A2 is the slope of the production possibility frontier, which is the opportunity cost of good one. And the opportunity cost of good one is lower at home. Meaning if home wants to produce additional units of good one, it gives up less units of good two than the foreign economy. And for such reason, we say that the home economy has a comparative advantage in good one because it has a lower opportunity cost. And similarly, the foreign country has a comparative advantage in good two because it has the lower opportunity cost. We're going to see very briefly that it's according to the comparative advantage the countries trade. And what's very interesting is that countries will always have a comparative advantage in a good, right? With the exception of the case in which the technology in the two countries is identical, so that this inequality does not hold because the unit labor requirements are the same in both economies. No matter how you move around, we play around with the numbers here, the foreign economy will always have a comparative advantage in something. And you can apply this to everybody, okay, even to yourself. No matter how unproductive you are, there's going to be something for which you have a comparative advantage. And there's going to be something that if you do, you're gonna give up less of whatever other things you could do than everybody else. Now, given these assumptions, we can now actually determine the patterns of trade. But now let's compare the two autarky situations in the home and foreign economy. Now we said that the unit labor requirements are such that the opportunity cost of good one is lower at home than abroad. This implies, since we mapped relative unit labor requirements or opportunity cost with the autarky price, that the autarky price of good one is lower at home than it is abroad. What does this mean? Well, this means that the production possibility frontier at home is going to be flatter than the production possibility frontier abroad. And for such reason, home is the cheapest producer of good one, and the foreign economy is the cheapest producer of good two. What's going to happen under trade? Well, this is the typical condition that you've derived in the previous course. But this is what's going to be new here, because we're actually going to derive the trade price. But the idea here is that the trade price, P1 over P2 with this superscript T, is going to be somewhere between the two autarky prices. That's because if the home economy is the cheapest producer of good one, and the trade price of good one is lower than that, it means that the home economy, which is the cheapest producer of good one, will not find it profitable to produce good one, and as a result, nobody would buy good one. Similarly, if the relative price under trade of good one is higher than the most expensive location, which is the foreign economy, everybody would produce good one, but nobody would produce good two. And so long as you have trading and positive productions of both goods, the relative price will be somewhere between the two autarky prices. Now, how do we derive this? Well, by setting the demand equal to the supply. Here we're not going to look at the absolute demand, we're going to look at a relative demand. So we're going to look at the relative demand for good one over good two, aggregate, right? Both the quantity of good one in the home economy plus good one in the foreign economy divided by good two in the home economy plus good two in the foreign economy. And that's going to be just a function of relative prices. Okay? That's because the relative demand does not depend on income, because we assume that the utility is homothetic. Okay? So this is very important because basically if we had now made such an assumption, we had that the relative demand would depend on income, then there would be a role for the income of the two countries in determining the patterns of trade. So if you're, say, a rich economy, you demand more of a particular good, well, perhaps that's a good that you're going to have a comparative advantage in. Now, that's very important, and it's a very interesting subject to analyze, but we're not going to do it. We're going to keep things simple and just focus on supply factors. So that's why we make this simplifying assumption of homothetic preferences. Now, we have a relative demand. We're not going to specify a functional form here. We'll specify it in the problem sets. Once you have a utility function, you can easily derive the relative demand for two goods. But what about the relative supply? Well, let's derive it. And this is going to be the main novelty relative to what you studied previously. So let's have here the relative price of good one, and on the horizontal axis, the relative quantity of good one. So we're going to have different cases. Let's start with the case of, in which the trade price is lower than the autarky price at home. We said the home is the most efficient producer of good one. So if the relative price in trade is lower than that, nobody produces good one. So that means that so long as the price is lower than the autarky price at home, there's going to be zero production of good one. Okay, so the relative quantity is going to be zero because Q1 is always going to be zero. Now, what if the trade price actually equals the autarky price at home? Well, if that is the case, the home economy is indifferent between producing good one and good two. Right? They're in the same situation of autarky, so they can produce anywhere along the production possibility frontier. The foreign economy instead keeps on producing only good two, right? Because the price of good one is much cheaper than their autarky price, so it's much more convenient for foreign consumers to buy good one from the home economy and sell good two. And so here the relative supply is going to be a horizontal line, right? That's going to stop. It's going to stop at a point in which the home economy is only producing good one. Okay, so anywhere on this point, the foreign economy produces good two. The home economy produces a combination of good one and good two. Then the most interesting case is the case of full specialization of the two countries. And so what we have here is if the trade price is between, without the equal sign, between the autarky price at home and the autarky price abroad, we're going to have the home produces only good one, right? Because now producing good two is no longer convenient. It's as if the home economy sees that the price of good one after trade increases. And so what they do, they jump into producing good one and forget about good two. Right? They sell good one for the higher price, they buy good two for the lower price. The foreign economy keeps on producing good two. And so here you have full specialization, where the quantity of good one is produced by the home economy and the quantity of good two is produced by the foreign economy. Then, if the trade price is exactly equal to the autarky price abroad, we have a similar thing that we had before. The home economy keeps on producing good one, and the foreign economy is indifferent between producing good one and good two, because they're in the autarky situation again, and so they can be anywhere along the production possibility frontier. And so we have here the horizontal part again of the relative supply curve. If the autarky price of good one, if the trade price of good one is higher than the autarky price of good one in the foreign economy, well, then nobody produces good two, right? And so here we would have, infinite relative supply. But again, so long as production of both goods occur, that case will not happen. So this is a relative supply curve. You can see it's a step function, and its crossing with the relative demand curve will determine the trade price. Okay? Notice that it's not always the case that the trade price will be exactly between the two autarky prices, because it really depends on the size of the countries. You know, if L is very large, well, you can imagine that this vertical point begins much later, and so maybe the relative demand curve will cross the relative supply curve in the horizontal part there. And similarly for the foreign economy. So basically, when you solve this problem, you have to check the various cases and see where the relative demand curve crosses the relative supply curve. So once we found the trade price of good one, we can see what happens to the countries. So let me put my face back up again. So this is the beauty of the Ricardian model. Here we have the autarky case for the home economy. Since the trade price of good one is higher than the autarky price, production moves. We go along the production possibility frontier so that everybody is working in a home economy in producing good one. Okay, full specialization. And then we can sell good one in international markets for a higher price than before. So the budget line is going to be higher than the budget line in autarky. So trade allows us to escape the tyranny of autarky. Our production does no longer limits our consumption. We can specialize in what we do relatively better, or we can do giving up less of the other good and trade it for in exchange for the other good. Okay, and we're gonna have a new utility curve, which is gonna be higher than the autarky utility indifference curve, and that means that trade increases welfare. Okay, same thing for the foreign economy, where here we show the imports and export of the home economy. Obviously, production of good 2 is 0, and so if we consume Y2T units of good 2, that's also the value of our imports. We only produce good 1, so the difference between Y1 and Y1T, our consumption of good 1, is going to be the export. Okay? And then for the foreign economy, the similar thing happens. In this case, the foreign economy specializes fully in good 2, so they produce Y2 star. They trade Y2 star for the good 1, which for them has become cheaper, right? For them, the price of good 1 is lower than the autarky price of good 1. So Y2, good 2 became more expensive, good 1 became cheaper. And so what they do is they trade it for good 1. They're gonna consume in a point in which the indifference cost is higher than the autarky case, and so welfare is higher. And here they have the exports and the imports. Obviously here, they're not drawn to scale. Okay. Obviously you may wonder, are exports gonna need to be equal to imports? Well, they need to be equal in value. Right? So here you can imagine that one good is apples and the other good is computers. It doesn't make any sense to think that the number of apples that you export must be equal to the number of computers that you import. Right? But what we have here is that trade is balanced. So the value of your exports, the number of oranges that you export, times their price, that's the value of export, must be equal to the value of the import. Okay? Another important point about the Ricardian model is that there is full specialization. Okay? Home country is the only country in the world that produces good 1. And the foreign economy is the only country in the world that produces good 2. Okay? This is very important because you remember when the lockdown first began last year in March, then there were a lot of controversies because it turned out that China was the only producers of masks and other COVID-related products. And obviously at the time, people didn't really know what to do, and so they thought that that situation was suboptimal. Okay? Some people blame it on globalization, and they thought that we need to reshore some of the production of medical supply. Fair enough. But what surprised me was that people were surprised that that was actually the case. Because here we have a simple model, the Ricardian model, that exactly predicts the country will fully specialize in the goods in which they have a comparative advantage in. And so if good one is masks, and China has a comparative advantage in producing masks, China will produce masks, and it will be the only country in the world to do so. Notice here that we haven't seen any wages, right? So the partners of trade are not determined by the wages. They're determined by the relative unit labor requirements, determined by technology, and they're determined by the opportunity costs. What about wages? Well, let's see about them. Now, recall that the home economy has an absolute advantage in everything, because there's lower unit labor requirement in both good 1 and good 2. Well, that also means that as we saw before, the opportunity cost of good 1 equals the autarky price of good 1, which is lower than the trade price of good 1. Okay? What are wages under free trade? Well, in the home economy, the only wage you get is from working in industry 1. If you work in industry 2, since output is 0, you get a 0 wage. So you won't do that. So what you do is you work in industry 1, and your wage is the price of good 1 on the free trade divided by A1. Same thing for the foreign economy. In that case, you only work in industry 2, so the wage is the price of industry 2 divided by the unit labor requirements in industry 2 abroad. Which of the two wages is larger? Now, here it's a simple proof here, but why don't you try? Why don't you pause the video and try to see if you can quickly show why, which country has the higher wage? And what you get is that since the home economy has an absolute advantage, it actually has the higher wage. And this is a quick proof, as I mentioned. It's like if we said that the wage is the relative price of good 1 divided by A1, this is obviously higher than the home wage that you will get in industry 2, right? The price of good 2 divided by A2. And since home has an absolute advantage in industry 2, that means that this wage, this fraction is actually larger than P2 over A2 star, which is actually the wage abroad. Oh, so it's not that China is exporting to Denmark because they have low wages. No, it's that China exports to Denmark because it has a comparative advantage in some goods. It has lower wages because it has a worse technology. Okay? So this is key. Technology here is driving the partners of trade and is also driving the standards of living. Of course, you hear a lot about working condition in China and in other low-income countries. Is that driving the results? Is that driving the fact that China is exporting the goods? Not really. Certainly may help with the competitiveness of Chinese firms, but we should remember always that standards of living from the Ricardian model, and we'll see some data in a second, are mainly determined by the technology. In other words, by the labor productivity. And the country that has the higher labor productivity will have the higher wages. So even if working conditions improve in China, it's very difficult that the wages will improve drastically. And thinking that it's the working condition that's keeping the wages low really misses the point. It's all about technology, or rather, it's mainly about technology. Let's not forget about it. Now, let's very quickly summarize the takeaway of this model. We have that countries specialize in the goods in which they have a comparative advantage. They benefit from trade because by doing so, they're able to expand their consumption possibility frontier. The price of the good they export increases so they can actually buy more of the other good, and then overall utility increases. The second takeaway is that these patterns of trade, the fact that countries export particular goods, determines on the relative productivities and the relative productivity of labor across sectors. You export a good that you produce relatively better. And finally, standards of living are determined by the absolute advantage. Beautiful. Let's see some evidence for this. Here we have a picture that I really like because it's very simple and very straight to the point. This shows the relationship between the wage across countries relative to the United States and the labor productivity relative to the United States. And as you can see, there's a beautiful positive relationship between the two. You can see there are some deviation from the straight line, right? So perhaps working condition, worst working condition put you below the line, maybe, who knows really. But what you see is clearly that if you want to have higher wages, you need a higher productivity. I think I really like to do in this course is to bring in some data. Okay? I told you in the introduction of the course that trade is a weird animal because it really combines theory with data. And that's what I want to do in this course as well. So what I thought for this course to do is to look at some data for Denmark. Let's look at Denmark's comparative advantage industries. Okay. Now we're going to look, how do we define a comparative advantage industry? Well, we need to know the opportunity cost. Right? That's very difficult to know. And so to go around that, let's just take a very coarse measure of comparative advantage and just look at exports and imports. And in particular, let's look at the difference between these two. And so we saw before that countries only export in comparative advantage. So we think if you export more than what you import in a particular sector, chances are that you have a comparative advantage in that sector. Okay. Obviously, there's better measure of revealed comparative advantage, but for the time being, let's just stick to this simple measure. And you can get all the data from Statistics Denmark. Okay, and I invite you to look at it. Perhaps you'll be surprised by what you find. And what I was surprised when I looked at this was the incredible performance of chemicals and related products, which we'll see is mainly driven by pharmaceuticals. Now, on the left panel, we have exports and imports as the share of export and imports of a particular industry as a share of total exports and imports in 2019. You see that chemicals account for almost 25% of exports, machinery also 22%, and then you have other sectors there. Okay, you see transport equipment. This is a funny example since we all know that Denmark does not have really a car industry, right? Doesn't have a car company, and it has this infamous high registration tax. And you see that there, your imports are much higher than your exports. Okay? So this is the level. On the right panel, I show you the percentage difference between exports and imports. So you see that in chemicals, the exports are more than 100% of the imports. Right? And in the transport equipment, there's about 50% difference. Okay. Now, in total, Denmark exports more than it imports, right? Not by not by crazy numbers, but by about 10-15%. Now, let's look at some more details, okay? In other words, from this figure, we can actually, if you look at the statistic Denmark's, not only you have the total value of exports at the chemical and related products, okay, but you can also dig into this sector and look at products within it. And so that's what I did here. I look at some products that sounded interesting to me and caught my attention. You see medicinal and pharmaceutical products, you have this tremendous export performance. So there's more than 50% of the total Danish export are made of pharmaceutical products. Okay, this is incredible. Then you have generally industrial machinery, right? Power generating machinery. That's some mid preparations. And here I showed you, and these industries, you have clearly perhaps a comparative advantage in case you're exporting more than what you're importing. And then obviously in petroleum, there's not really an oil extracting industry of a decent scale in Denmark, and so you import more than you export. Same thing for electrical machinery and road vehicles. I also included dairy products here. You see, it counts for less, but you still have a positive difference between export and imports. If we look at the percentage difference between export and imports for these products, you clearly see where the comparative advantages lay in, right? And perhaps at this point, you're starting to see where I'm going with this. Because here you have pharmaceutical products, dairy products, power generating machinery, meat and meat preparations, and general industrial machinery. Those are products in which Denmark exports more than 100% of its imports. In some case 200, in some case 300%. Okay? In other sectors instead, the opposite is the case. And so why am I selecting particularly these sectors? Well, because in Denmark, you know that you have a few very large firms that are very competitive in the international markets. Right? If you think of pharmaceutical product, Novo Nordisk come to mind, dairy products, Arla, power generating machinery, Ørsted, Vestas, industrial machinery in general, well, probably Grundfos is in there. Then unfortunately, Statistic Denmark, they didn't give data for toys, but perhaps Lego is also part of the picture. But so the question is it about the country or is it about the big firms in one country? And this is the question that the author of the little article that's in the reading list for today's lecture asked. But let's see, with the words of Oleg Itskoki, one of the two authors here, what the paper is about.
The big question that we started with was, can individual firms shape the trade patterns of countries, right? Can it, if you give a specific example, for example, to what extent Finland is particularly good at producing tires and cell phones, and it would always be good at producing tires and cell phones, or it was just a kind of like draw of luck that Nokia, which was the biggest firm in the country, specialized, had the technology in tires and cell phones, and that shaped the export patterns of Finland for a long period of time, right? And so we want to address this question systematically in a larger country than Finland across many industrial sectors, right? Where the role of one single firm is not as pronounced, but nonetheless, you have this very large firms, and to what extent, they drive the export patterns of countries, right?
And so in this paper with Cécile Gobert, who's at Berkeley, Itskoki recently moved to UCLA, University of California, Los Angeles. They precisely study the question that we just asked. Okay, so does Denmark have a comparative advantage in pharmaceutical products because Denmark has Novo Nordisk, or because in Denmark there is an overall relatively better technology? In other words, is Denmark exporting so much pharmaceutical product because the opportunity cost is low because of the industry opportunity cost being low, because of competencies, factors of production, and other things that we'll see in the future lectures? Or is it because Novo Nordisk has some managerial competencies or other abilities such that it has such better technology that it's driving the export performance of Denmark? That's what they do in this paper. And I thought to talk a little bit about it in this class, because typically we think that the Ricardian model is an old model, and so maybe it's an abandoned model. And I wanted to show you that that's not the case. People are still investigating the issue of comparative advantage, obviously with more advanced and sophisticated tools than the one you learn in the first trade lecture of your life. right? But still, the intuition that we're developing is enough to understand what they're doing. And so, as I mentioned, you can think that there's two sources of comparative advantage or two types of comparative advantages. One is a fundamental one that's driven by technology, common across all the firms in an industry. And then there is the presence of these very large firms, okay, superstar firms, which they label as granular comparative advantage. If you look at the articles, there's some uh, very famous cases. For instance, there used to be a facility of Intel in Costa Rica, and so you'd see in the data that Costa Rica had crazy exports of microchips. Okay? Then when Intel moved, that stopped. Okay, so that meant that the comparative advantage of Costa Rica in microchips was mainly driven by the presence of a superstar firm or a very large firms and not by a fundamental comparative advantage. Okay? So they investigate this empirically, applying their model using French data. And what they find is that about 20% of trade flows are granular. Okay, so if you want to explain the export patterns of a country, right? So if we look at Denmark, if you want to explain why Denmark is as a comparative advantage in, say, pharmaceutical, in power generating machinery, and so on, well, on average, using the French data, what they find that that's explained by 20% for the presence of large firms. Okay? And the remainder 80% is due to technology. So, sorry, is due to, technology common across all firms. Okay? And then what they show also is that there is a fast reversal of comparative advantage. So you're likely to lose your comparative advantage much faster if you have sectors with superstar firms. You can think that technology evolves and changes in technology perhaps are different across countries. So the comparative advantage of countries changes over time. You know, if you think about textile, perhaps you know that textile used to be the biggest industry in the first wave of the industrial revolution. So it was in England, then it moved, was some in Italy, but also in the US, first in New England, and then you moved south of the US. After World War II, you had perhaps some textile production in Italy. Now it's mainly in Southeast Asia. And so you see the comparative advantages evolve. Right? What they show is that when your comparative advantage is based on the presence of a large firm, of a superstar firm, these changes occur much faster. Okay, so that's it for the Ricardian model. Thank you very much for watching. See you next time. Ciao.